Okay, so this is basically the magnitude Bode plot. Okay, now take a good look at this one. Can make sure that you guys can see the whole whiteboard. Yes, so take a good look at this magnitude plot. What kind of filter do you think this plot is? Is it a low pass filter, high pass filter, band pass filter, all pass filter? What kind of filter it is? Or what frequencies do they get attenuated when they go through this transfer function? Okay, you can pause the video and think about it. You see here, this point, there's nothing getting attenuated here, right? So this is like a low pass filter, which attenuates the magnitude of higher frequencies, right? You see that as you go higher, the magnitude gets smaller, right? If you don't follow this, let me actually tell you this, right? H of j omega is VO over VI, right? So it means that the magnitude of VO is going to be magnitude of VI times magnitude of H of j omega. At higher frequencies, this would have a smaller magnitude. So it means that your output, it's going to end up with smaller magnitudes compared to your input voltage. So that's why this is called a low pass filter. It means that passes the low frequencies but attenuates the higher frequencies. Okay, so this is all about doing the Bode plot. Just keep that in mind, that Bode plot is not exact. It means that if you actually sweep the frequency and analyze the magnitude using a simulation software or using power analyzer like oscilloscope or power analyzer, different methods, you might get something like this, right? It's not going to be exact. It's just a good approximation. Okay, it's just a very good approximation, right? And it serves its purpose, right? The purpose is just to get an idea of what's the frequency behavior of our circuit or our transfer function. Now, let's look at the phase plot. That one is a little bit challenging, okay? So if you want to take a break and come back to it once you're fresh. Okay, so here again we are doing this same transfer function. The poles are 1 and 100, and we only have 1 0, which is equal to 10. And we also found out that H of 0 it's 100. What is the magnitude of H of 0? If you have a real number, what is its magnitude? It's 0, right? If this was 100J, it would be 90. But if it's real, it's going to be 0. Okay? So now let's again do the same thing. Plot this. This is omega. This is magnitude or phase. This is phase of Hj omega. Okay, and you remember I mentioned that the scale for this axis depends on your example. So here we know that our poles are at 1, 100, and then we have a 0 at 10. So I'm gonna start this one with 0.01, or I could actually start it with 0.1 as well, doesn't matter. And 0.1, and then 1, 10, 100, 1000, and so on. Okay, because I know nothing is gonna happen up to this point. Well, actually you see that like something happens here, but I know that things are gonna happen around the pole or 0. Okay, so we know that at omega equal to 0, our angle is 0 degrees. Okay, let me actually go this a little bit higher, 0 degrees. Excuse me. So now we have a pole here. Okay, so I'm gonna go here, but I'm gonna stop 1 decade before the pole. 1 decade before the pole. Now, for the phase plot, I'm just gonna write this. The impact of a pole or 0 starts from 1 decade before until 1 decade after. Okay, and so it means that like the impact of a pole or 0 only lasts 2 decades. Okay, and at each decade, when you have a pole, at each decade the magnitude, it's gonna drop with the rate of negative 45 degrees per decade. Okay, negative 45 degrees per decade. Let me actually do this here. And it's gonna stop 1 decade after. So this is gonna be sorry, let me actually make it more clear here. So it's gonna start here, it's gonna go down, and then it's gonna stay like this. If we didn't have any other poles or zeros, this would be the thing that happens. If you start at 0 degrees at this omega equal to 1, what's gonna be the angle? Negative 45 degrees, right? Because the slope of this one is negative 45 degrees per decade, right? And if we didn't have any other poles and zeros, then our phase would settle down at negative 90 degrees. Okay? But what happens here is that we have another, sorry, we have a 0 here. Okay, we have a 0 here. What's the impact of a 0? Exactly the opposite of the impact of a pole. Okay, so what's gonna happen at this point? It means that the impact of it, it's gonna start